This lesson is for section 7.1. It's on the Pythagorean theorem. We're going to talk about perfect squares in this video. These skills are necessary for doing the problems that involve the Pythagorean theorem. So what is a perfect square? Well, if you take your natural numbers and you square them or multiply them with themselves, that gives you a perfect square. So 1 squared is 1 times 1, that gives you 1. 2 squared is 2 times 2, that gives you 4, so on and so forth. 3 squared is 9, 4 squared is 16. You get the idea. The perfect squares are the numbers that are blue on this screen. Now, there is a PDF file in the Files section for channel 7.1. You could print out this sheet and keep it in front of you when you're working on the problems. If it helps you, when you print it out, it's probably not going to have the numbers as blue. You can put a box around these numbers to help you. These are the numbers that are perfect squares. So we're very interested in what these perfect squares are and what they mean and how they can help you. Now, we only have the first 25 listed here. There's obviously infinitely many perfect squares because you can square any number you want and get a new perfect square. But notice how there are numbers that are not perfect squares. For example, the numbers 2 and 3 and 5, those are not perfect squares. So what's going to happen in this section is we're going to have to take the square root of a number. So when you square something, you're multiplying it with itself. When you take the square root of a number, that's what that symbol means, you're actually finding what number times itself gives you that number. So you're basically unsquaring. The square root is like unsquaring a number. So what is the square root of 4? Well, what times itself gives you 4? 2 does. Now, there's also another answer as well. -2 times -2 gives you 4 as well. Okay, so there's a positive root and a negative root. So using this list, you can find the square root of numbers pretty easily, especially if the numbers are perfect squares. So for example, the square root of 169 is 13, because 13 squared, 13 times 13, gives you 169. Now, eventually we're going to do problems that are a little more tricky. For example, what happens if we were looking for the square root of, let's just say 13? What times itself gives you 13? Check your chart. Notice how 13 is not a perfect square. But notice how 13 is in between 9 and 16. We know the square root of 9 is 3, and we know the square root of 16 is 4 because those are perfect squares. So what that tells you is the square root of 13 lives in between 3 and 4. And you can get a little more technical with it if you'd like. 13 is definitely closer to 16 than it is to 9. So what that means is 13, or the square root of 13, maybe I'll write it down here. The square root of 13 is probably pretty close to, I'm going to say maybe 3.6, something like that. Because 3.6 is closer to 4 than it is to 3. Okay, now you can actually just type this into your calculator also. If you know how to square a number using the squared button on your calculator, the square root button is the second function for that same button. So I'm just going to type it into my calculator right now. Square root of 13, it does give me 3.6. 3.60555, da-da-da-da-da. What we'll actually do is round to the nearest hundredth when we're looking for those. So if this is 3.605, I'm going to call it 3.61 because 605 has that 5 in that position. I'll write it out for you. If I'm only keeping 2 digits, I'm going to keep a 60 or I'm going to make it a 61. Those are my options. Now I chose to make it a 61 because the next digit to the right there is 5 or above. So that's how we're going to use this perfect square list to help us when we are encountered with radical expressions.